You're swimming over a coral reef when suddenly a rock transforms in the blink of an eye, shifting colors and textures to perfectly match its surroundings. That was an octopus vanishing before your eyes. Nature's color-changing superpowers are far more than camouflage. They're weapons for hunting, shields for survival, and languages for communication. Let's uncover how animals wield them. Chameleons are the world's most famous color changers, and for good reason. Watch one perched on a branch shift from muted brown to brilliant green in seconds, a transformation that reveals how this superpower actually works. The magic lies in specialized skin cells called chromatophores and iridophores. Chromatophores sit closest to the surface and contain pigments, xanthophores for yellow, erythrophores for red, and melanophores for brown and black. Beneath them, iridophores are packed with guanine nanocrystals that reflect and refract light. When a chameleon's nervous system signals these cells, pigment disperses within chromatophores, while iridophores adjust crystal spacing. That coordinated dance alters which wavelengths of light bounce back to your eyes, all in milliseconds, using surprisingly little energy. But here's what might surprise you. Chameleons change color primarily for communication and temperature regulation, not camouflage. While they can make minor adjustments to match their environment, their most dramatic color shifts are triggered by social and physiological needs. Each hue tells a story, from "I'm ready to mate" to "I feel threatened" or "I need to warm up." Color change is their multi-tool for survival and social signaling. The chameleon reveals nature's first lesson about color-changing superpowers. They're not just about hiding. They're living mood rings, thermostats, and conversation starters all rolled into one biological system. But what happens when nature cranks color changing up to 11? Meet the octopus and cuttlefish, masters of instant transformation that make chameleons look like beginners. Picture an octopus hunting along the ocean floor. In a fraction of a second, it morphs from smooth purple to bumpy brown coral, complete with matching texture. This isn't just color change. It's total visual metamorphosis. While chameleons adjust pigments in their chromatophores, octopuses and cuttlefish control millions of these cells, plus specialized muscle fibers called papillae that physically reshape their skin surface. One moment they're flat and smooth, the next they're sprouting spikes, ridges, and bumps that perfectly mimic rocks, coral, or seaweed. Their chromatophores work like tiny elastic sacs filled with pigment, each surrounded by muscle fibers. When these muscles contract, the sac stretches wide, spreading color across the skin. When they relax, the pigment retreats to a tiny dot. With millions of these working in perfect coordination, an octopus can create moving waves of color, checkerboard patterns, or even flashing strobe effects. But here's where it gets truly mind-blowing. They use these patterns as a sophisticated visual language. A cuttlefish can split its body down the middle, showing aggressive warning stripes to a rival on one side while displaying gentle courtship colors to a potential mate on the other. They're literally having two different conversations at once, each painted in living color across their skin. This level of control transforms color changing from simple camouflage into something approaching telepathy, direct visual communication that bypasses sound entirely. After reading about octopuses splitting their body colors to have two different conversations at once, do you think you could handle being that social? Comment your answer below. Now let's discover an animal that takes color changing to an even more extreme level. But some animals take color changing beyond instant camouflage and communication. They completely transform their entire appearance across seasons, like living chameleons that swap entire wardrobes. Arctic foxes and ptarmigan birds master the ultimate long-term color change. As winter approaches across the tundra, these animals don't just adjust a few pigments. They shed their entire summer coats and grow completely new ones. An Arctic fox's rich brown summer fur, perfect for blending with rocky terrain and sparse vegetation, gradually gives way to pristine white winter pelage that makes them nearly invisible against snow and ice. This transformation isn't controlled by chromatophores like the octopus or chameleon. Instead, it's triggered by changing daylight hours that signal their bodies to produce different types of hair follicles. The summer coat contains melanin-rich guard hairs in browns and grays, while winter growth produces hollow, air-filled hairs with no pigment at all, creating that brilliant white appearance while also providing superior insulation. Ptarmigan birds undergo an even more dramatic makeover. Their summer plumage features intricate patterns of brown, gray, and rust that perfectly match alpine rocks and low shrubs. But as snow begins to fall, they molt into pure white feathers, keeping only their black tail feathers and eye patches. Some populations even change 3 times per year: summer brown, autumn gray, and winter white, tracking their environment's color palette with precision timing. This seasonal color changing reveals nature's most patient superpower. While octopuses change in milliseconds and chameleons in seconds, these Arctic masters plan months ahead, growing entirely new disguises before they need them. They're not just adapting to their world, they're predicting it. Some animals turn color changing into a dazzling real-time performance that makes a Broadway show look understated. The peacock mantis shrimp bursts with color, hues of bright red, green, orange, and blue, its entire body a living light show. Unlike the octopus's instant camouflage or the chameleon's mood ring displays, peacock mantis shrimp use rapid color changes for both camouflage and communication. But here's what sets them apart. They perform elaborate courtship dances and aggressive territorial displays, orienting their bodies to showcase the brightness and reflectivity of their colored patches. These aren't just colors, they're biological spotlights. Mantis shrimp's eyes have at least 12 types of photoreceptors, which increases the speed at which they can identify colors. Their visual system is so complex that they truly see the world in full color, able to perceive wavelengths that humans can hardly imagine. They're essentially wearing Technicolor armor while living in a world painted in colors we can't even perceive. But the ultimate masters of color as status are mandrill monkeys, where facial coloration becomes a living billboard of social rank. Males with the brightest red noses and most vivid blue facial ridges typically have the highest testosterone levels and hold dominant positions within their social hierarchy. Dominant males display the brightest faces and rumps, signaling strength and fitness to rivals and potential mates. Submissive or lower-ranking males tend to be duller, almost like they're turning down the volume on their colors to avoid confrontation. Females respond directly to this visual hierarchy. They allow the brightest colored males to approach and are more likely to groom and solicit them. These animals have evolved a visual hierarchy so precise that other mandrills can accurately assess a potential rival's strength or a potential mate's fitness at a glance. It's nature's most honest dating app, where your face literally broadcasts your status, health, and genetic quality in real time. Color-changing abilities are nature's ultimate multi-tool for survival. Chameleons use color as a mood ring and thermostat. Octopuses paint entire conversations across their skin. Arctic foxes grow entirely new wardrobes for winter. Mantis shrimp turn their bodies into living light shows. Each animal has evolved its own signature approach to wielding color as a tool for survival. But here's what makes this superpower truly remarkable. It's not a rare trick. Warning coloration has evolved hundreds of times independently in butterflies, beetles, bugs, sea slugs, poison frogs, and birds. Camouflage and aposematism coexist in the same regions. This isn't one clever invention that a few species stumbled upon. It's such a powerful survival strategy that evolution has independently created color-changing abilities again and again across completely unrelated animal families. Recent research deployed more than 15,000 artificial prey with 3 different colors, each baited with a mealworm, to measure survival rates. The results confirm what these animals have known for millions of years. The right color at the right time can mean the difference between life and death. What makes color changing truly extraordinary is its versatility. It's simultaneously a shield against predators, a weapon for hunting, a language for communication, a thermostat for temperature control, and a billboard for attracting mates. No other single biological system serves so many critical functions at once. These color-changing superpowers reveal nature's most fundamental lesson. Adaptability isn't just helpful, it's everything. In a world where conditions change by the season, the hour, or even the second, the animals that can transform themselves are the ones that thrive. Subscribe for more amazing animal superpowers and check out
our night vision video next.